Hello dear students, today we are going to continue with our series Algebraic Identities. In this part, the identity that we are going to learn about is a plus b into a minus b equals to a square minus b square. Sometimes you might have seen the same identity with the notation x plus y into x minus y equals to x square minus y square. The variables that have been used here are only symbols. They do not hold any other relevance. For example, we could have used some other letters as well. If we would have used C and D, that is C plus D into C minus D, it would have been C square minus D square. Or else, for that matter, if we had taken a bat and a ball, bat plus ball into bat minus ball would have been bat square minus ball square. So, consider these letters as symbols only. Let us verify the identity with the help of product of any two algebraic equations. So, the equation that we are taking is 2x plus 5 into 2x minus 5. You can take any other equation of the same form to verify the identity. So now, using distributive property, we will multiply the quantities of the first bracket one by one with the quantities of the second bracket, or else you can do the other way around as well. So first, 2x is multiplying the quantities of the second bracket, 2x minus 5, plus 5, the second quantity of the first bracket, is also multiplying 2x minus 5, the quantities of second bracket. Now, 2x into 2x, first 2 2s are 4, x into x, x square, so 4x square. Next, 2x into minus 5, plus into minus, minus, 2 5s are 10 into x, 10x, so minus 10x. Now, plus 5 into 2x, plus 5 2s are 10 into x, 10x, so plus 10x. And finally, plus into minus, minus, 5 5s are 25, so minus 25. Now, in this equation, 10x and minus 10x, they are equal and opposite, so they'll cancel each other. So, we'll be left with 4x square minus 25. 4x square can also be expressed as 2x whole square minus 25 can also be expressed as 5 square. Now, if you can see, 2x was in fact the first term of the bracket and 5 was actually the second term of the quantities in the bracket. So, we have got the first term square minus second term square. So, considering a as 2x and b equals to 5, we will have a plus b into a minus b equals to a square minus b square. So, the identity has been verified. Now, since we have verified the identity, let us apply the identities to find the product of the algebraic equation of this form. The first question is 5x plus 9 into 5x minus 9. Considering 5x as a and 9 as b, we can use the identity a plus b into a minus b equals to a square minus b square. A over here is 5x, so 5x whole square minus 9 square. Now remember, 5 and x, they are two terms, and whole square means the square is for both 5 as well as x. So let us do it like this till the time you don't understand the concept. Once you have understood the concept, you can skip the step. 5 square into x square, since square is for both, 5x whole square minus 9 square. 5 5s are 25, x square will remain x square minus 81. The difference between 5x whole square and 25x square is 5x whole square means the square is for both 5 as well as x. Now 25x square means we have already squared 5 and the square is now simply for x square since there is no bracket. The bracket was suggesting square is for both. So you need to understand this fact. The square has already been done. 5 5s are 25 and x square is there. Now the square is only for the variable. Moving on to the next question now. 4y plus 5 into 4y minus 5. Considering 4y as a and 5 as b, since a plus b into a minus b equals to a square minus b square, so 4y whole square minus 5 square. 4 4s are 16, y is a y square minus 5 5s are 25. So the answer is 16y square minus 25. Next question, 2 by 5k minus 3 into 2 by 5k plus 3. The question is slightly different from the ones which we had done before, as the quantities with difference are now in the first bracket and the quantities with sum, they are in the second bracket. But since the two quantities are in the relation of product, so it won't be any different, as 2 4s is 8 and 4 2s will also be 8. So we just need to make a minor change in the formula. So now since a minus b is coming first, a minus b into a plus b, the identity will remain the same, equals to a square minus b square. So 2 by 5k whole square minus 3 square, a square minus b square. 2 2s are 4, 5 5s are 25, k square will remain like that, minus 3 3s are 9. So this is our answer. Next, 3x plus 2i into 3x minus 2i. Now both the quantities have variable. So considering a as 3x and b as 2i, since a plus b into a minus b equals to a square minus b square, we will have 3x whole square minus 2i whole square. First, let us multiply the coefficients. 3 3s are 9. Now the variable x x are x square minus 2 2s are 4, y into y square. So the answer is 9x square minus 4y square. Using the same identity, we can find the product of the numbers as well, which can take up the form of a plus b into a minus b, or the other way around. For example, the product of numbers 87 into 93 here. 87 can be expressed as 90 minus 3. 90 minus 3 is 87. And 93 can be expressed as 90 plus 3. So considering a to be 90 and b to be 3, we have a minus b into a plus b equals to a square minus b square, equals to a square, that means 90 square, minus b square means 3 square. 9 9s are 81. We have 1 0, and since it's squaring, we'll get 2 zeros at the end. 8 1 0 0 minus 3 3s are 9. So if we'll subtract, the result will be 8091. So the product can also be calculated like this quite easily. Next question, 118 into 102. Try to do the sum always on the bigger number. So 118 here is the bigger number, so we'll try to have the sum in the bigger number. 110 plus 8 into 110 minus 8. 110 minus 8 will be 102. So a here is 110 and b is 8. Since a plus b into a minus b equals to a square minus b square, so a square is 110 square minus b square is 8 square. 11 11s are 121, and since we have 1 0, so on squaring we'll get 2 zeros. 121 0 0 minus 8 8s are 64. So the subtraction will give us 12036. So this is also done. The quadratic equations which do not have the middle term can be factorized using this identity. For example, let us consider this quadratic equation, 81x square minus 4. Now see, the middle term is not there. The term with x is not there. So 81x square, since 81 is square of 9, 9 9 is 81, and 4 is square of 2, 2 2s are 4. We can write it like this, 9x whole square minus 2 square. 9 9 is 81, x square, 81x square, and minus 2 2s are 4. So now this is taking the form of a square minus b square. Now let's flip the identity, since a square minus b square can be written as a plus b into a minus b. So this can be expressed as 9x plus 2 into 9x minus 2. So the factorization is done. Let us do one more question. 121 by 25 y square minus 49. Here the coefficient of y square is in fraction, 121 by 25. But both the numbers, they are perfect squares. 121 is 11 square and 25 is 5 square. So we can write the number as 11 by 5 y whole square minus 7 7 is 49, so 7 square. Now this is again taken the form of a square minus b square, where a is 11 by 5y and b is 7. Since a square minus b square equals to a plus b into a minus b, so this can be factorized as 11 by 5y plus 7 into 11 by 5y minus 7. Next example, 25x square minus 36y square. Both the terms have variables. 25 is 5 5 is 25, 5 square. 36 is 6 square, 6 6 is 36. So 5x whole square minus 6y whole square. 5x we can take as a and 6y we can take as b. So since a square minus b square is a plus b into a minus b, so we can express this as 5x plus y into 5x minus y. Next question, 16x square minus 5. There's no problem with 16 as 16 is a perfect square number. 4 4s are 16. What's a perfect square number? The number which can be obtained by multiplying the same number twice. For example, 1 1s are 1, 2 2s are 4, 3 3s are 9. So 1 4 9, 4 4s are 16, 16, 5 5s are 25, and so on. So 1 4 9 16 25. These are perfect square numbers as they can be obtained by multiplying the same natural number twice. 5 here is a non-perfect square number. So how can we express a non-perfect square number in a form of square? So in order to do that, what we can do is we can put the non-perfect square number under square root like this. 4x whole square as 4 4 is 16, x x is x square minus under root 5 square. The square will cancel under root and will give us back the 5 that we had. So whenever we have a non-perfect square number, we just need to put that inside square root and then square it. So here 4x is a, root 5 is b. So since a square minus b square is a plus b into a minus b, we'll have 4x plus root 5 into 4x minus root 5. So this question is also done. Now these are assignment questions for you which are based on same questions that we have discussed in the video. So try to solve all of these, and if there are any problems, let us discuss.